This is Mr. Ashton going through the Mathematics Unit 2 Calculator Allowed Intermediate Tier paper from the November or autumn of 2016. Okay, so first page is always the formula list. We may come back to it, may or may not. The next question, or the first question, says, using only the numbers in the list, write down a prime number or a cube number, factor of 186, multiple of 7.25, and so on. Okay, so prime numbers have only got one factors, which is themselves and 1. Two factors themselves and 1. So 57, I know, goes into the 3 times table. I can check that by doing 5 add 7 is 12, so therefore it must go into it. It can't be any of the even numbers because 2 goes into all those. That leaves us with 59, 61, 63, and 65. We should know that 65 has got 5 in it. 63 has got 7 times 9 makes it. So that leaves us 61 or 59. It's actually, they're both primes. So 59 or 61 will suffice there. A cube number is a number times by itself and times by itself again. And that would be 64, which is 4 times 4 is 24. 4 times 4, which is 16. 16 times by 4 is 64. A factor of 186, I am going to use my calculator this time, means that it must go into 186. So what I'm going to do is start doing 186 divided by 2. See, that's 93, so it's none of those. Divided by 3 is 62, so 62 would work there, okay? And a multiple of 7.25. The factor ends in a 0.25. I'm going to times that by 4 to begin with. So 7.25 times by 4 gives me 29. So then let's try doing that twice as much. Times by 8 would be 58. Okay then. It then says, circle the correct answer for each of the following statements. One angle in a right angle triangle is 60 degrees. The other angle must be, now the key word there is that it's a right angle triangle and it has 60 degrees. We know they've got to add up to 180. That's 90 from the right angle, and 60 makes 150. So then it would be 30 to make it up to 180. We're then told that 3 angles of a quadrilateral add up to 250. So we should know they add up to 360. So it's not 360. We're looking for what adds 250 to get us to 360, which would be 110. We're then told that Hugh is facing north. He turns clockwise until he is facing west. So let's go and draw what that looks like. So never eat shredded wheat. He turns clockwise until he's facing west. So 1, 2, 3/4 of a turn, which would be 270 degrees. Okay, then over the page it says shade the least number of squares in the lower 2 quadrants so that the grid has rotational symmetry of order 2. Now, for it to have order of rotational symmetry order 2, I'm going to use some tracing paper here. You may see that I've drawn on it before in the past. It doesn't matter, I can still use the spare bit, so don't throw your tracing paper out. There, and there, and there. Okay, now they want it in the lower quartile, so I'm just going to sketch also the origin. So when I do a spin, there, half a spin, it shows me where I'd have that to have 2. If I want it to be like order 4, I would do the quarter spin and so on. But it only wants order 2. So order 2, that fit on itself once in half a spin, and then go back here twice for order 2. So going back to where that was using the origin there, the marker there will show me. And I'm going to press down really hard. So there, 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 there. So I'm just going to mark those squares now. I'm just marking the corners of them. So that's the square. We've got the rectangle there. And then we've got a square there. So moving that away now, I'll just shade those so that they come through nicely, okay? It doesn't have to be the best shading in the world. This would suffice. Okay. And over the page, we've got solve the equation. 3x minus 2 equals 10. So if we add 2 to both sides, we get 3x equals 12. And then we divide both sides by 3, so no need for a calculator for that. The answer is 4. It then says a number machine is shown below. Input, add 5, multiply by 7, output. Calculate the output when the input is minus 2. So minus 2 comes here. We then add 5. Minus 2 add 5 is 3. 3 times 7 is 21. We're then asked to write down an expression of the output when the input is n. So this time, we're going to put n in. We're then going to add 5 to it, and then we're going to times it by 7. If I write that, I don't get 2 marks, I only get 1, because it's going to penalise me for not using BIDMAS. The first thing I did was n plus 5, so I need to have brackets around that, but I could write it as 7 bracket n plus 5, that would also be fine. Okay, so either of those two are fine. Question 6. Complete each row of the following table. The first row has been done for you. In Holyhead, it was -1 degree Celsius. It went up by 3 degrees, and -1 add 3 took us to 2 degrees. We're on -3 degrees, and we've gone to 1, so we've gone up 4 degrees Celsius. We're on 2, we've gone down 3, so that takes us to -1 degree Celsius. And then what went up 2 to get to -2? It must be -4 degrees Celsius there. Okay. Question underneath is missing angles in a quadrilateral, which we already know from before is 360 degrees. It must be that angle, that angle, that angle, and this angle here, which I don't know. But I can go and work it out by doing 125 taken away from 180, which tells me that angle must be 55 degrees. So now adding all those together, just show the examiner that's what you're doing as well. So we know when we're marking what your thinking is, because if something goes wrong in your calculator, you'll still pick up method marks. That gives me 246 degrees, and now I just do 360 degrees, take away that 246 degrees to get 114 degrees. Okay? Okay, then over the page it says, show clearly why the following statement is show clearly whether the following statement is true or false. If you increase a positive number by 10%, then decrease the new value by 10%, you get back to your original number. Now it sounds like it makes sense. We're going to choose a number to see if this is true. Okay, so as we're working percentages, we're using 100 will be a really nice number to use. 100 as a number. We're now going to go and work out 10% of 100. 10% of 100 is equal to 10. So increase is equal to 100 add 10, which is 110. Okay, so far we have done this bit here. If you increase a positive number by 10%, we've done that bit. Then it says, and then decrease the new value by 10%, you get back to your original number. Well, we need to test if that's the case. So go and work out 10% of 110, which would be 11. We're decreasing that, so we're doing 110 take away 11, which is 99, which is not 100 because that's not my original number, so false. Okay. Question 8, it says, circle either true or false for each of the following statements below. All equilateral triangles are congruent. Now that's not true. All equilateral triangles have angles of 60 degrees, but we could have a tiny triangle that big that all have angles of 60 degrees, and we could have a much bigger one which have angles all of 60 degrees, and they're not congruent. Congruent means they are exactly the same, that I could go and fit one on the other, so that's false. All squares with equal areas are congruent. Now that's true, because to be a square, all the sides must be the same, and you must do a side times a side to get side squared there. So if that area is the same, then the sides must be the same. Circles with equal perimeters are congruent. Now, that wouldn't be true if it was a rectangle necessarily, but when we're talking about circles, because the formula to work it out, if that's my radius, would be 2 pi r, then it would stand to reason that the radius must be the same, therefore the areas must be the same. So yeah, that would be true. And all regular octagons are congruent. Well, no, for exactly the same point as my triangles. Octagons that are regular means all the sides are the same, so exactly the same idea there, but just imagine an 8-sided shape and 8-sided shape, so that's false. Okay then, question number 9. It says, you will be assessed by the quality of your organisation and communication and accuracy in your writing. We're told that a square has a perimeter of 80 centimetres. A circle fits exactly inside the square as shown. Calculate the circumference of the circle. Give your answer correct to one decimal place. You must show you're working. Okay, so starting with this statement here, they'll all be in order of what we need to do to unlock it. So if a square has a perimeter of 80 centimetres, all sides must add to 80. That's the definition of being a perimeter. So if we call the sides, I don't know, let's call it x, we don't know it. That side would then be x, that side would then be x. They'd all be x because they'd all be the same. We could say that 4x is equal to 80. So then dividing both sides by 4 tells me that x must be equal to 20 centimetres. So we'll put an arrow there. We don't need to write an essay. We can just say one side of the square equals 20 centimetres. Now, if we look at this side here, that is also the distance from one side of the circle to the other. Okay, so we can say, so the diameter of the circle is also 20 centimetres. Okay, so we now know what that distance through circle is. That's 20 centimetres. We're asked in the question to go and calculate the circumference of the circle. The formula for a circumference, we use 2. It doesn't matter which one you use. You can either use c equals pi times diameter, or you can use c equals 2 times pi times the radius. Well, I know that 20 centimetres goes the whole way through the circle, which I've already said is the diameter, so I'm going to use this one. So the circumference must be equal to pi times by 20. So c equals pi times 20, s here, which is 62.8 centimetres to 1 decimal place. Okay, and I envisage this would be fine to get all the marks there, all 6. The next question is quite an easy nth term one, which would actually wrong foot you and make you likely to say the wrong answer here. Usually we go and look at the sequence and say, oh look, they go up all by 2s or all by 3s or all by whatever. They're not usually all by 1s, but they're all going up by 1s. So we usually say that is going to be the number that is going up in front of n. 1n, we could have just said n. Now what we need to do now is find this term here that would be in front of 3. So if we take away 1 there, that would be a positive 2. So my sequence would be 1n plus 2 or just n plus 2. Either of those are fine. We're then told that the nth term of a different sequence is given by n squared plus 7. Write down the first 3 terms. So to find the first term, we just sub into n squared. We change it to open brackets and sub in 1 for the first term, sub in 2 for the second term, sub in 3 for the third term. If I want to find the 10th term, I'd sub in 10. 1 squared is 1, add 7 is 8, 2 squared is 4, 4 add 7 is 11, and then 3 squared is 9, add 7 is 16. So now I just need to go and write those terms 8, 11, 16 in there. We're then said which term, they bolded it, is in the sequence which is the first that has a value greater than 85. Okay, so we use our formula here to create an equation. N squared plus 7 is greater than 85. Okay, now to do that, I'm going to take 7 off each side to get n squared has got to be greater than 78. And then to work out what n is, I need to square root both sides. So I need to do the square root of 78, which would give me 8 and a bit. So n has got to be bigger than 8 point something. Well, we can't have an 8 and a bit term. We have a first term, a second term. We don't have a 1.5 term. So here we're saying it's somewhere between 8 and 9. It's got to be bigger than 8 and a bit. So my first term that would be bigger would be the 9th term. And if I go and sub in, you don't need to do this, but I'll just show you. If I go and show you what 8 squared plus 7 is, that will be less than 85. And then 9 squared plus 7 will be more than 85, which shows why we've just answered what we needed to. So 8 squared plus 7 is 71, so less than 85. And then 9 squared plus 7 is 88. So it's bigger, so it does it. Okay. Question 11, we're asked to reflect the triangle S in the line y equals 2. Now people struggle with this line. Y equals 2 does what it says on the tin. Y is 2. You go and draw a line through that value. So here, there. Okay, that's y equals 2. Now I count the vertices, the corners from the line. So 1 away, 1 away, 1 away, 1 away. And then finally 1, 2, 3, 4 away. So from the line 1, 2, 3, 4 away. And it should look like if I folded that line, these two triangles would meet up on themselves perfectly. Make sure that looks like it's properly on that line there. Okay. The question over the page, we need my tracing paper back again. It says, describe fully a single transformation which transforms S onto T. Now, when we talk about transformations, there are 4 of them. We've just seen one that was a reflection. Okay, you can also have a rotation. You can also have an enlargement. And you can also have a translation. Okay, now a lot of these do what they say on the tin. Reflection, does it look like it's looking back at itself in a mirror? No. Rotation, does it look like it's being spun around? Yes, it does. So it could be a rotation. Has it got any bigger or smaller? No, it's the same size triangle. Has it been moved from one place to exactly the same way, pointing up, etc., somewhere else? No. So by process of elimination, it has to be a rotation. Okay, now this is 3 marks. Okay, so to get the 3 marks, we obviously don't get it for just writing rotation. We now need to say where S has been, what angle it's been rotated, and from where. So we get our tracing paper, find some spare space, and I trace triangle S, and I'm going to go and pick the origin as a good place to start. Okay, so I always go and draw a crosshair through it. I now put my pen on the middle of the origin to see if I spin the tracing paper, does it land on it? It does there perfectly, okay? So we now know that it is the centre of rotation is at 0, 0, or the origin, and that is a quarter turn anti-clockwise from S, okay? So I'm going to say centre 0, 0 / origin, either of those would be fine. And then I need to say 90 degrees, which is a quarter of a turn, and it was anti-clockwise. You could say that it was 270 clockwise, okay? And if I go and show you that, there, look, if I move it round, that's a quarter of a turn, 1 quarter, half a turn, 2 quarters, 3 quarters turn, 270 degrees, okay? Over the page, we're then asked to translate triangle S using the column vector, okay? Now, the column vector is quite easy. It's in alphabetical order. So X will be moving it left or right on the X-axis, and then Y will be moving it up or down. We've got to pick a corner, pick a vertex, and we need to take 5 off X. So currently here, this one's on 1, so we go 1, 2, 3, 4, 5. So it's now going to be here. And then I need to take 4 off Y. So 1, 2, 3, 4 there. Okay, I now would repeat the same for each corner, but I like to say this is 1, 2, 3 squares along, so it has to be 1, 2, 3 squares along here. The base is 1, 2 squares along, so it has to be 1, 2 squares along here, and that's also translated it, okay? Hopefully you're thinking that's pretty simple. If you look at the marks, it's only worth 1 mark, so it should be. And then we're asked to write down a column vector that will reverse the translation. So to move that back, I need to add 4 onto Y and add 5 onto X. So I just look at this vector here and just reverse it. So it would now be a +5 and a +4. Okay? Okay, then question 12, page 13. So circle the correct answer for each of the following. X to the power of 3 times x to the power of 6. You should know that you add together the powers of indices, so it would be x to the power of 9, so that one there. This one here is particularly complicated, all because of this minus here. That's the one that's going to do the damage here. There's no need for that first thing to be in brackets. 7x minus 5y can come out of the brackets, because it's not having a number times outside it, okay? Now this one you'd look at and say, well, nor's that one, but it is. It's got a minus sign, which is minus 1 times in that bracket. Minus 1 times 3x would be minus 3x, and minus 1 times plus 2y would be minus 2y, okay? Now that's where you're likely to have gone wrong, that you didn't have the minus there, but you had the minus the 3x. I've then got 7x minus 3x, so that would be 4x, and then minus 5y, take away a further 2y, would be minus 7y. So 4x minus 7y is the one I'm looking for there. The next one, part C, says a car travels X miles in 30 minutes. Its average speed in miles per hour. Now that's the key word here, 30 minutes per hour. They're not the same. We need to go and change 30 minutes into hours. 30 minutes past is the same as saying 0.5, which is the same as saying half past, okay? Half past will be 0.5. Now, drawing your speed, distance, time triangle will help here as well. Speed is equal to distance over time. I've been asked to go and work out what its speed is. Let's make sure that looks like a T. So speed would be the distance, so x miles, divided by the time, which is 0.5 hours. I don't like dividing by a half. So what we do is we times top and bottom by 2, and that becomes 2x divided by 1. 2x divided by 1 is 2x. My answer is this one here. Okay, then over the page, question 13 is a question on trial and improvement. Whenever we're doing this, we're doing a couple of things. The first thing to identify is the numbers that they give me there. I'm going to sub into that equation there. It will get me a mark. The second thing to identify is the number of decimal places it asks you. You always go one more. So we're going to go to 2 decimal places, but only once to check, okay? Now, the next thing we're going to do is draw a table. So I'm going to draw a nice long table here and here. Nice skinny columns at the end, and then a nice big fat one in the middle. X goes there. My equation, 2x cubed minus 3x minus 17 equals 0 goes there. And I comment on it in the last column. Okay, I will start off choosing the numbers they've told me it's between. I will get a mark for doing that. To do that, all I need to do is change the x to open brackets to begin with. Inside the bracket goes the number that I'm guessing. So I'm going to say 2 bracket 2 cubed minus 3 bracket 2 minus 17. That comes to minus 17, which is too low because I'm supposed to get 0. I've done all the hard work, so I use the replay button, I delete the 2 and change it to a 3, and I get 28. Okay, that's too high. I'm supposed to get 0. Okay, so we've just proved what they told us is absolutely true. Now, if you're unsure, the best place to go to now is 2.5. However, I can see that 2 is much closer to 0. The answer for 2 is much closer than the answer for 3 is. So I'm going to try like 2.3. Okay, so into my calculator goes 2.3 in both the brackets. And when I get that, we can see we get a slightly positive number here. So sorry, 2 went there, 3 went there. So 2 brackets 2.3 cubed minus 3 brackets 2.3 minus 17 is 0.434. Now that is only ever so slightly too high. We're supposed to get 0, it is 0 point something, it's positive, it's just too high. So we're going to go 1 lower, okay, or 0.1 lower. You only ever go in consecutive numbers here. Because that's too high, I now need to go lower. So I'm going to do 2.2. And we get minus 2.304. So just write all of these things down. I know it's a pain, but there's marks for showing all your working and all your thinking. Okay, that's too low. Now, so far, I've picked up 2 marks. Here when it went low, high, here when it went high, low, and these numbers here, the 3 and the 2 are both there. Okay, now I need to choose which one is closer, and I can sort of tell just by looking at the answers. However, I've got to show that by doing this bit here that I mentioned before. You go to 2 decimal places, once. Now, effectively, we've chosen 2.2. We found out that the answer was too low here. Try a bigger number. We tried 2.3 and we said, well, this is too high. Try a lower number. So what we're going to do is cut this line exactly in half. So at 2.25. So at 2.25, I now go and put that into my calculator. So 2.25 in both brackets. And that equals minus 0.96875, blah, blah, blah. Okay? Now, the most important thing is that it's minus, which means it's too low. Now, as soon as I do that, I get a 3rd mark. Because this is too low, this is telling me to choose a higher number. So it's got to be somewhere on that number line, somewhere between these 2 figures here, so closer to the 2.3. Okay? So x must equal 2.3 to 1 decimal place. That's it in terms of the 2 decimal places. We only do that once, as I said. Okay, have a quick read of the question. I'll start going through it in about 10 seconds. Okay then, it says, at a college, a total of 28 students study one or more of the science subjects of biology, chemistry and physics. The students from the universal, the 28 students from the universal set E. Some parts of the Venn diagram have already been completed. It is also known that 5 students study only biology, 13 students study chemistry. Complete the Venn diagram. Now, we know there's got to be 28 people in here because they told us there are 28 students. There's no one on the outside, and that's because they all took, it says they studied one or more of these subjects. Okay? Now, the next important thing is that we know that 5 students study only biology. So this part of my circle here is only biology. We now know what that is. This has got to be 5. Okay, so that's pretty easy. I can just go and fill in a 5 there. Okay, now the other one is the way it's worded. 13 students study chemistry. So all of this circle here is chemistry. So all of this must add up to 13. Okay, so what we know so far is that we've got 6 there who studied all 3 sciences, 2 who did biology and chemistry, so that's 8 in total, and 1 who did only chemistry, so that's 9 in total. There are 13 students who study chemistry, so this must be 4. Okay? Then I need to work out the number of students who only study physics. So to do that, I'm going to do 5, add 2, add 1, 5, add 2, add 1, add 3, add 6, add 4, add these guys here. So that's all of my students accounted for so far, which is 21. And because it's 28 students, that leaves me with 7 that must have done physics alone. We're then asked how many students studied biology and chemistry, but not physics. Now, they've already told us that answer there, it's filled in there. Biology and chemistry, not biology or biology and chemistry, but not physics, so it's just these 2 guys here. So the answer is literally 2. It then says one of the students is chosen at random. What is the probability that this student studies biology? So to work out they study biology would be all of this circle here, which is 5 and 2, which is 7, add 3, which is 10, and 16. So that's 16 out of 28 students. Okay, no need to cancel down that fraction. It doesn't ask me to do that. That is a probability regardless. Question 15. It says the diagram shows the graph of the straight line from the values of x to -3 to 3. Write down the gradient of the line. Now, to work out a gradient of the line, I need to find some nice points where it goes through some coordinates I can find easy. So that is definitely one of them. Okay. Now, that's going to be my next one there where I can see it goes through the grid lines there. I'm going to draw a triangle now, like so. And I need to work out what is the base of that triangle and what is the height of that triangle. The height of that triangle goes from 4 to 6, which is the height of 2. And it has gone from 0 to 1, which is a base of 1. To work out the gradient of something, I use the formula rise over run. So it's risen 2 and run along 1, so its gradient is 2. Okay, 2 divided by 1 is 2. We're then asked to write down the equation in the form of y equals mx plus c. Now, m is gradient, is 2. Okay, they've already done that bit for us, so we know it's going to be y equals 2x. The plus c bit is where this graph here, where that hits the y-axis, and that hits the y-axis at 4. What sort of 4? A plus 4. So it's y equals 2x plus 4. The next question here says, without drawing, show that the line 2y plus 5x minus 3 is parallel to 4y equals 10x plus 7. You must show appropriate working for your answer. Now, we need to have things, to compare things, we need to have it in the form y equals mx plus c, and this is 2y equals mx plus c. So what I'm going to do is I'm going to divide everything by 2. So 2y divided by 2 is y, 5x divided by 2, minus 3 divided by 2. Okay? Similarly here, I want to get y by itself, so I'm going to divide everything by 4. So I'm going to get 4y divided by 4, which will just be y, 10x divided by 4, and then plus 7 over 4. Now, to be parallel, the main thing I'm interested in is the gradients. It's this guy here and this guy here. Okay? Now, you will notice here that I could cancel down 10 over 4 to being 5 over 2 by halving each of them. This is here, 5 over 2, so I'm going to say gradients are the same, in brackets 5 over 2 or 2.5, so parallel. That's the definition to be a parallel line. It has to have the same gradient. Question 16. Have a quick read of it. I'll start going through it in a moment. Okay then, it says a factory uses a machine to produce electrical sockets. The manager carries out a survey to investigate the probability of a machine producing a defective socket. The relative frequency of the defective sockets produced was calculated after testing of 1,000, 2,000, 3,000, 4,000, and 5,000 sockets. The results are plotted on the graph below. How many of the first 3,000 sockets tested were defective? So we look for 3,000 on the graph here, go and read off what its relative frequency of defective sockets was. And I can see that it is bang in the middle of 0.04 and 0.06, which must be 0.05. Its relative frequency, 0.05, times by the number of sockets, times by 3,000, will tell me the number of sockets that were defective. It's rather like doing your probability by the number of trials to work out your expected probability. So that would be 150 defective sockets. We're then asked to write down what is the best estimate that the probability of one socket selected at random will be defective. Okay, now your best estimate is always at your highest number of trials. The more trials you do, the more accurate your answer is. And I can see that that is one little square below 0.05. So what I need to do is work out what the scale is. So I've gone up from 0 to 0.2, so that is a jump of 0.02, divided by 10 little squares. So 0.02 divided by 10 gives me an answer of 0. Oh no, it's given to me in standard form, which would be 0.002. We should know that without a calculator, in all honesty. So we now know we've come back from 0.05. We want to take away 0.002. So if we do 0.05, take away the answer that I had, we get 0.048. Okay, so that's my best probability, 0.048, and the reason is because most trials for best accuracy. Okay, then over the page, quite a nasty circle theorems question coming to a calculator paper as well. Okay, a bit mean question this one because you might miss the actual topic it's working on. You'd look at that and assume it's circle theorems, but there's something else in it as well. We're told that points A, B, C, and D lie on the circumference of the circle. O, B, D is the diameter of the circle. So this here is the diameter of the circle. Now you will notice from here that I have got points coming here and here. We will know that angles on a straight line add up to 180, and you should know that this angle here is always half of that, which would be 90 degrees. That means we've got a right angle triangle in here. Okay. Now we are asked to go and work out the size of BDC, B to D to C. So to B to D to C is this angle here. Okay. We're then asked to go and calculate the length of BD, the diameter, to go and work that out. Now, we do actually know this angle straight away here. This angle must be 28 degrees because this theorem here, okay? Now, it doesn't actually ask me. It says write down the size of angle BDCE. BDC, there, is 28 degrees. And that is because angles in the same arc angles from the same arc are equal. Okay, it's just a case of going and learning those circle theorems. Now we know that we've got a right angle triangle here. If I'm just going to draw it around this way now, the 90's there, 28's at the top. We know the base there is 4.7. Well, I don't know why I'm doing this actually. I can just label it here. If that's 28 degrees, that's opposite it. That's opposite the right angle, so that's the hypotenuse, which I want to find, and I know the opposite. This would be the adjacent. They want me to go and use trigonometry here. Okay, so to do that now, I'm going to write SOHCAHTOA. Because I know the opposite and I want to find the hypotenuse, I'm going to cross those out of SOHCAHTOA. I'm going to choose SOH because it's double crossed out. So I'm going to say sine angle, so sine 28 is equal to the opposite side, so 4.7 divided by the hypotenuse, which I don't know. I don't like the fact that I don't know the hypotenuse, so I'm going to times both sides by the hypotenuse. So I get hypotenuse times sine 28 is equal to 4.7, And then to get the hypotenuse by itself, I'm going to divide by sine 28. That'll leave me with the hypotenuse, and in my calculator goes 4.7 divided by sine 28. Okay, to get 10.01, 10.0 centimetres to 1 decimal place. Okay. Question 18, and very nearly it's the last question, and it's got 2 parts. Okay, have a quick look at it, and I'll start to go through it in a moment. Okay then, so the last question is on something called factorizing. So you'll notice there we have a minus 24, and you'll notice here we have a minus 2. Now both those values are really important if you're factorizing. You're thinking of a pair of numbers that times together to give me minus 24, and they have a sum they add together to make minus 2. So if I have a pair of numbers that times together to give me minus 24, the only way I can do that is by having 1 plus and 1 minus sign. So plus minus, plus minus, plus minus. I'm going to write it out a couple of times because there's lots of combinations that times together to make 24. Starting with 12 and 2. 12 take away 2, its sum is 10. That's not minus 2, so that's not my pair. Think of another pair that times together to make 24. So 8 and 3. 8 take away 3 is 5, so that's not my pair either. 6 and 4. And that makes 2. Now that's not minus 2, but it is 2. So if I switch around the 4 and the 6, I would get minus 2. That's my pair. Okay, so to factorize x squared minus 2x minus 24 and then put it equal to 0, I can put x in 2 open brackets, plus 4 goes in one, minus 6 goes in the other. Okay, now these 2 brackets are timesing each other, so I'd say that either x plus 4, this bracket equals 0, or the x minus 6 equals 0. To then solve that, I want to take 4 from each side to get x equals minus 4, or add 6 to each side to get x equals 6. So if I go and sub in there, minus 4 squared, minus 2 times by minus 4, and then minus 24. I haven't put a bracket around that bit there. I get the answer 0. And if I put in 6 as well, I get 0. Okay, they're the only 2 numbers that will do that. Any other numbers that go in there will not work. Okay, finally then, part B, it says solve the following equation. Okay, now the thing that we don't like is the denominators. If I have numbers like 2 add 3 equals 5, and I times each of those by 10, 2 times by 10 is 20, 3 times by 10 is 30, 5 times by 10 is 50, you'll notice that it still works. 20 plus 30 is indeed 50. So what I'm going to propose to do is look for a number that would knock out all the denominators. So I've got a 2, a 6, and a 2. Now 6 is the biggest one, and you'll notice that 2 goes into 6. So 6 is a really good number to times everything by. So I'm going to times the first thing. So 4x minus 3 over 2, I'm going to times it by 6. I'm going to then add 7x plus 1 divided by 6. And then I'm going to have 629 over 2. Okay. Now, the reason why I've times by 6 is I know those 2 guys cancel out. These guys don't cancel out, but 2 goes into 6 3 times. 2 goes into 6 3 times. So now I want to expand this bracket. 3 times by 4x is 12x. 3 times by minus 3 is minus 9. Plus, and then that bracket will stay exactly the same. Nothing's going to change there. And then 3 times by 29, I obviously don't know. So I'm going to put it into my calculator. So 3 times by 29 is 87. I'm now going to collect my x's. So 12x add 7x is 19x. Minus 9 plus 1, we should know that anyway, but it's minus 8 for safety. And then that's equal to 87. We're now going to add 8 to each side to get 19x is equal to 95. And then finally, we're going to divide both sides by 19. So 95 divided by 19 is 5. So x equals 5. Okay, that was the last question on the paper. Hopefully you found that useful. If you did, please hit the subscribe button and you'll get access to any more videos as and when I release them. Thank you very much for watching.